Alright everybody, we're on chapter 8.2, which is dealing with the factor and remainder theorem. And go ahead and just hit the pause button if you want to and copy down the remainder theorem, which reads, when you divide a polynomial p of x by any factor x minus a, which is not necessarily a factor of the polynomial, you'll obtain a new smaller polynomial and a remainder. And this remainder is the value of p of x at x equals a, for example, p of a. And so let's go ahead and just look at this problem number 1 right here, and let's identify our parts. This polynomial, any polynomial we're talking about, is the larger one here. So this would be my p of x right here. And here would be my binomial x minus a. So when I divide this factor x minus a into the polynomial p of x, I'm going to use synthetic division. And I'm using synthetic division because my leading coefficient in x minus a is 1. And I'm going to go and copy down my coefficients here. It's 1, negative 6, 2, and negative 4. So I'm going to go ahead and synthetically divide. I get 1 here, a 2, a negative 4, a negative 8, a negative 6, a negative 12, and a negative 16. Negative 16 being my remainder. So my new polynomial is going to be x squared minus 4x minus 6. So what my answer becomes, if this is a question in the homework, is I'm going to rewrite the polynomial up here as p of x is equal to my quotient, or in this case sometimes they refer to it as q of x, times my dividend, which is x minus a, plus or minus my remainder. Oops, wrong thing. Okay, so let me show you what that looks like in terms of concrete terms. My p of x is going to be x to the third minus 6x squared plus 2x minus 4 is going to equal my quotient, so x squared minus 4x minus 6, times my binomial, so x minus 2. In this case, since my remainder was negative 16, it'll be minus 16 over the original divisor. Okay, and this will be my answer right here. And we will get into what this means in a second, but for now I just need you guys to know that that's what we're doing. So let's do another example here. Let's say I was to ask you to divide this polynomial p of x into this binomial x minus a. Again, with the leading coefficient as 1, it's better to use synthetic division. I'll go ahead and set this up. And so I'm going to go and synthetically divide. I get a 1, a 4, a 5, a 20, a 7, 28, 3, 12, 0. Okay, my remainder is 0 in this case. So my new polynomial is going to be x to the third plus 5x squared plus 7x plus 3. So that means that my answer is going to be my polynomial, and I'll go ahead and just write it a little bit over here, x to the fourth plus x to the third minus 13x squared equals, let me scroll over here, I'm going to run out of space, equals my quotient times, and I'm going to take up 2 lines here, times x minus 4, and that's it, because I can't add any other 0 to it. So let me go ahead and hit the pause button real quick, and I need to put another theorem on there, and then we'll discuss these two problems. Alright, I'm back. The factor theorem says that the binomial x minus a is a factor of f of x if and only if f of a equals 0. In this case, f of a did equal 0, right, because this is f of a. And so what we can conclude is that x minus 4 is a factor of this polynomial. So looking back at example number 1, because we had a remainder of negative 16, we can say that x minus 2 isn't a factor of the larger polynomial. The next piece is called synthetic substitution. And synthetic substitution is used just to figure out will we have a remainder when we plug something in. And synthetic substitution and direct substitution are somewhat interchangeable. The way they work out in a problem is going to be exactly the same. So if I do a problem, like say number 1 here, if I want to try to find f of 2 of a certain function, I'm going to give us the function f of x equals x to the third minus 2x squared minus x plus 1. And so what I'm going to do is I'm going to synthetically divide 2 into this function here and see what I get as my remainder. 1, negative 2, negative 1, and 1. So when I synthetically divide, I'll get a 1, I'll get a 2, I'll get a 0, a 0, a negative 1, a negative 2, and negative 1. So this is my remainder right here, but let's see what happens if I directly substitute in f of 2 into the equation. So if I go f of 2, what that's going to give me is 2 to the third minus 2 times 2 squared minus 2 plus 1. So 2 to the third is 8. This is 4 minus 8 minus 2 plus 1. Those are going to cancel each other out. Negative 2 plus 1 is in fact negative 1. And what do you know? Our answers match. What this tells me is that somewhere on this graph, when I plug in 2 for my x, my output is going to be negative 1. So this is where f of 2 is. It exists at this point right here. All right, that's what synthetic substitution tells you. And so synthetic substitution and direct substitution, they're pretty much interchangeable. Yeah, on the quiz, I'll let you decide which one you feel like doing more. Sometimes it's easier to do direct, sometimes it's easier to do synthetic. It really is up to you. Okay, let's get into the meat of the lesson, which is given a polynomial and one of its factors, find the remaining factors of the polynomial. So let's go ahead and write a problem out here. X to the third minus x squared minus 5x minus 3, semicolon, x plus 1. Now, they say given one of its factors, so this is one factor. And by virtue of it being a factor, what that means is that there must be a remainder of 0. Alright, so when you synthetically divide this thing, you should end up with a remainder of 0 as your remainder. If you didn't, you have done something a little bit wrong. So let's go ahead and expect a 0 here. So we've got 1, negative 2. This is going to be positive 2, and this is going to be negative 3, and this is positive 3. What do you know? I get 0 here. Remember, in synthetic division, my exponents get downgraded, so this is x squared now, minus 2x minus 3. And it says to find the remaining factors, which means that this thing, hopefully, is factorable, and in this case it is. My two numbers that multiply to 3 and 1 are 3. I'm sorry, multiply to 3 are 3 and 1. In order for me to create a negative 2, I need a negative 3 and a positive 1. So therefore, my remaining factors are x minus 3 times x plus 1. If I asked you for all factors, you would have to include the one that was given. So that would be x plus 1 times x plus 1 times x minus 3, or you could have simply written it as x plus 1 quantity squared times x minus 3. And if I had to guess at what this thing looked like, it's a cubic function which passes through at negative 1 twice, so negative 1 and positive 3. I would guess that it does this, something that looks kind of like that. It hits negative 1 twice on a double root right here, which is what we saw in 8.1. All right, let's do another one. All right, x minus 4 is one of the factors, so I'm going to go and synthetically divide. I get 1, 1, negative 16, negative 16. And I'm hoping to get a 0 right here, but let's see what happens. I get a 1, a 4, a 5, a 20, a 4, and a positive 16. What do you know? Good job. Thank you. x squared plus 5x plus 4. Let's go and refactor this thing into x plus 4 and x plus 1. So those are my remaining factors of this polynomial. Okay, that just about covers it. We'll see you next time.